So here's a common problem, a real logistical headache. How do you get a high-quality video signal from a computer to a screen that's like almost a mile away?
Right.
Your standard cables, they're just not going to cut it. You get maybe 15, 20 feet before the signal just turns to mush.
You'd just be running a giant antenna for interference if you tried that with copper. And that's exactly why today we're looking at the NTI ST-2FODVI-LC.
Okay.
It's a DVI extender, but the trick is it swaps out that copper for fiber optics to solve that exact problem.
And the mission here seems pretty straightforward then. Get a signal from A to a very, very distant B without it turning into a pixelated mess.
So physically, what are we talking about? Is this some massive rack mount unit?
You'd think so, but no. It's surprisingly small. It's a little transmitter and receiver set. You just plug the transmitter into your computer's DVI port, the receiver into the monitor, and the bridge between them. Well, that's where the magic happens. Two simple strands of LC fiber optic cable. LC connectors. Okay, so those are the little snap-in ones, the kind you see in high-density server racks. That actually makes it pretty easy to integrate.
It does, yeah. If you already have fiber in the walls and the range you get, it really depends entirely on the kind of glass you choose.
Okay.
If you're running, say, multimode fiber, you can push that signal up to 1,640 feet. That's about 500 meters.
Which is pretty good for a large building, maybe factory floor. But what if you need to go further, like across a whole campus or something?
Well, then you just switch over to Singlemode fiber. And get this, that pushes the limit to a staggering 4,920 feet.
Whoa.
That's 1,500 meters. We're talking nearly a full mile.
Wait. So you're telling me you can push a signal 1.5 kilometers. Are there repeaters in the middle, or is this a straight shot?
It's a straight shot. Because it's digital light, you don't have those same resistance issues you get with electricity over copper.
Right.
But we do have to talk about resolution. This is a DVI interface, so, we're not talking about 4K HDR or anything like that.
Sure, DVI is a bit of a legacy standard at this point.
It is, but for the things this is built for, industrial control panels, medical displays, that max resolution of 1920 by 1200 WUXGA, that's actually perfect. It's the standard.
So it keeps those critical legacy systems looking crisp.
Exactly, without needing a total digital overhaul.
Okay, so it handles the distance, it handles the resolution for its use case. But why fiber specifically? Is it just about the length?
No, it's really about isolation. I mean, think about it. If you're on a factory floor, or even worse, in an operating room, that environment is incredibly noisy electrically.
Motors, generators.
MRI machines. They're all blasting out radio frequency interference.
And a copper cable would just soak all of that up.
It would conduct it right into your image. You'd get flicker, artifacts, a mess. But since this is light in a glass tube, you get total electrical isolation.
Right.
You could literally wrap this fiber around a high-voltage generator, and the video signal wouldn't even notice. The source material actually calls out low RFIEME as a key feature for this exact reason.
That galvanic isolation, that's a huge deal for critical systems. But is the device itself rugged enough for, say, a roadside traffic cabinet or a factory?
It seems to be. The operating temperature range is pretty solid, from freezing up to 122 degrees Fahrenheit. And the form factor is tiny, like 1.5 by 2.7 inches, so you can just tuck it away behind a screen.
Okay, so my big concern with these kinds of black box extenders is always the handshake. Does the computer actually know what kind of monitor is a mile away from it?
And that's often where these things fail, you're right. But this one has a feature called EDID learning.
EDID learning.
Yes.
So it clones the monitor's profile.
That's a great way to put it. Yeah, essentially. The extender reads the extended display identification data from the monitor, and it just stores it.
Right.
So it basically tricks the computer into thinking that screen is plugged directly into it. Your PC doesn't default to some safe low resolution just because it can't see the display at the other end.
Which saves a ton of IT headaches, I'm sure. I see it's priced at about $709. That feels steep for a cable extender, but for industrial infrastructure, that's probably pretty cheap.
Especially when you factor in the 2-year warranty, it's really an investment in, reliability.
So it's effectively this invisible bridge for critical visual information.
It is. And, that kind of brings up a final thought to leave you with. Even as we see the consumer world move to wireless and the cloud for everything, the most critical infrastructure, think airports, hospitals, power grids, it all still relies on these physical beams of light pulsing through glass. It's invisible tech to most of us, but it's still the only thing that's fast enough and reliable enough to actually keep the world running.
It's a good reminder that the physical layers still matter. Thanks for listening to this deep dive. We'll see you on the next one.